Hello and welcome everyone. In this lesson, we're going to talk about the product rule. Now, the product rule is a very important rule that will help us to find the derivative of functions that is a product of two different functions. So I'm going to give you a few examples of such functions. So let's say we have the function y equals to x squared plus 5x and times 2x minus 1. So we use the product rule to get the derivative of such functions, where you can see that we have one function, we can mark it as f of x, and then we have another function, let's call it g of x, and it is a product of both of them. Another example could be if we have a function that looks like this, 2x plus 1 times 5x minus 1. Now you see that is a product of two different functions. So that's when we use the product rule. Now you guys might think that when we have a product of two different functions, what I mean is if we have a product of two functions as one whole function, you might think that the derivative would be the derivative of the first one, 2x plus 1, the derivative of this one times the derivative of the second one. But that is not the case. I'm going to show an example why this is not true. So let's say we have the function px equals to f of x times g of x, where my f of x is x squared plus 2 and g of x is x plus 5. Now we're going to show that the derivative of p of x is not equal to the derivative of f of x times the derivative of g of x. So let's see over here, we have our p of x, which is going to be x squared plus 2x times x plus 5. Now if I simplify this and expand it, I'm going to get x cubed plus 5x squared plus 2x plus 10. And if I have to find the derivative of this using the rules that we learned in the previous lesson, we can say that the derivative is 3x squared plus 10x plus 2. However, if I have to find the derivative of each of these functions f of x and g of x separately, what do I get? So the derivative of f of x would be 2x and the derivative of g of x would be 1. So if we multiply the derivative of f of x and the derivative of g of x, we're going to get 2x times 1, which is going to be 2x. So we can see that the derivative of p and the product of derivative of f and g is not the same. So hence we can prove that this is true. So what is the product rule then? A product rule is a simple formula that you can memorize and then you can use it. So here we can see the product rule. So the product rule states that if we have a function p of x which is equals to f of x times g of x, then the derivative of p of x would be the derivative of the first function f of x times g of x stays the same plus the first function stays the same times the derivative of the second function. All right, so for example, if we have a function y equals to x squared plus 2x times 3x minus 1, what we're going to do is, to find the derivative, we're going to use the product rule, and that will give us the derivative of the first one, which is going to be 2x plus 2 times the second one stays the same, plus the derivative of the second function, which is going to be just 3, and the first function stays the same. So that's how you use the product rule. Now you can simplify this or you can keep it as is. It's up to you. Let's do another example where we have a function y equals to 5x minus 4 times 7x cubed plus 2x squared minus 3x plus 1. Now, using the product rule, we get derivative of y equals to the derivative of first one, which is simply going to be 5. And the second function is going to stay the same. So I'm going to do 7x cubed plus 2x squared minus 3x plus 1 plus the derivative of the second function, which is going to be 21x squared plus 4x minus 3 times the first one stays the same, 5x minus 4. Now eventually you will have to learn to simplify it further and bring it to the simplest form. But for now, just know that this is the formula for product rule, and this is how you can find the derivative of a function that is a product of two different functions. Now moving on, we're going to talk about the power of a function rule. Now this rule is used when you have a function that is a function within a function. Now I'll explain what I mean by that. Now let's say we have a function 2x plus 1, and I bring the whole thing inside a bracket, and this whole thing has a power of 3. So over here I can assume that u equals to 2x plus 1. So what I'm doing here is I'm just giving another variable to define 2x plus 1, the function inside the bracket. So I can write the function y equals to u cubed. Now if I have to find the derivative of this, what do? I can just simply do 3u squared. But I have to keep in mind that is my function in terms of u or in terms of x. Now the original function is obviously in terms of x. I assumed certain part of the function to be u, but the actual function is actually in terms of x. But when I find the derivative, I actually find the derivative in terms of u. So what do we have to do? We have to find the derivative of u again, which is I have to find the derivative of the inside function again. So this is going to be 3u squared times derivative of the inside would be just 2, and then the last step I can just replace the u with my original function. So I'm gonna get 3 times 2x plus 1 whole square times 2. Now I can simplify this. 6 2x plus 1 whole square. Now that's how you use the power of a function rule. So that is used when we have a function inside another function. So that's pretty much it for this chapter. So product rule is the rule that we use to find the derivative of the function that is a product of two different functions. And we also learned how to find the power of a function rule. We learned how to find the derivative of a function that is within a function. So thank you so much, and I hope you join me in the next lesson.